Hello everyone, Jai Hind to all. Welcome to Digital School of Ajay Kumar Garg, Engineering College, Ghaziabad. In this video lecture, today I am going to discuss about the brief introduction of array. The first point is definition of array. In this topic, we discuss about how the array is declared, how the array is working with the given syntax. The next topic is declaration of array. In this topic, we discuss the different type of the array, how the character array is declared, how the integer array are declared, or how the string array are declared for programming purpose. The next topic is types of array. In types of array, we discuss different types of array, but mainly there are two types of array. The first one is one-dimensional array, that is called linear array, and second one is two-dimensional array, that is the part of multi-dimensional array. And multi-dimensional array is divided into different parts: two-dimensional array, three-dimensional array, and n-dimensional array. Why we use macro to define? This topic is concerned about the programming part. Macro means how the variable is defined before the main function. By using this concept, we have to define macro, and by the use of the macro, we speed up the execution of the program. The next is initialization of array. How the array is initialized? There are three basic concepts are used to show here: zero indexing, one indexing, and end indexing. The next one is calculating the length. This is the main part of the address calculation, how the length of the given array is calculated by using the reference value. In this topic, we discuss the total space acquired by a given array. The next one is the calculation of address of any elements. That means if I have the given array and we want to find the location of the given array, then we use a formula. By using the base address, we have to calculate the address of any elements at any location. And the last one is representation of array. That means how the array is represented inside the memory. By the use of this topic, we explain the all basic concepts. And the last one is application of array. In application of array, we discuss at which place array is effectively used. Okay, now the first topic is definition of array. Array is the data structure containing number of data value of which are the same type. That means if we declare int, then the array is only stored int value, like this. This is the name of the array, which is ARR. This is the type of the array, and this is the length of the array. This decides how much value in this array we will store. Data elements are stored at contiguous memory location. This is the basic concepts of array. Array is a type of data structure which store value in a contiguous memory location. That means each element having one previous element and one next element, like this. This is a array ARR. There are 4 positions in this array: 0, 1, 2, 3. If we want to access this element, we directly access by using the base address of the location of this array, and one element before this is this, and the next element is this. This is the basic concepts of contiguous memory allocation. Now, definition of data structure. How this array is work in a data structure, and what is the meaning of data structure we discuss here. Data structure is the format of organizing and storing data. Format means how the data is stored inside a main memory is called format. Like this is the memory, And in this memory, what is the structure we have to represent the given data is called organizing and storing the data. Also, each data structure is designed to organize data to suit a specific purpose. That means for a specific purpose, we have used a specific data type. If our data is simple and we want to perform a simple operation, then we use the array. If the data is complex or multi-level value, then at that case, we have to use tree and graph. One more data structure, if you want to implement a dynamic data structure, then we used link. But here we only discuss about what is the basic structure of array. For example, array is the data structure which you can visualize as follows. In previous slides, I saw how the array is created inside a memory. Here we also want to show how this array is work in a memory. This is the array which is created inside a main memory at a contiguous memory location. This is the first address 0, this is the 1, this is the 2, this is 3, this is 4, this is 5, this is 6, and this is 7. By using this concept, you have to create a contiguous memory allocation inside the main memory. The next point is, imagine an array is the large chunk of memory divided into a smaller block of memory, and each block is capable of storing a data value of some type. Some type means which may be integer type, which may be character type, which may be float type, or which may be defined as a primitive data type. By using that data type, we have to assign the value of that array of a particular data type. This is the declaration syntax of an array. Here we write int arr 10. 10 is the length of array. This is the length of array, and it must be a positive integer. The length of the array is a positive integer. This is the name of the array, which is arr. This is the user defined. We can take any name, which may be arr, ra, rb, what you want to take. We have to take any types of name according to the user defined. And this is the primitive data type of the array. That means if we want to store a value in a given array arr, we have to store only integer value like 5, like 8, 4, 9, 7, 13, 2, 6, 11 and 12. These all values are integer. If we want to store 9.5 here, we can't do it because the types of the data is must be integer. Here int arr, this is the another example of array. Int arr 8, that means the size of the array is 8. We start with 0 and 1, 2, 3, 4, 5, 6 and 7. Total value stored in this array is 8. This is the also name of the array. That means this is a location inside a memory which name is arr, and the value stored by the given array is integer type. This is so in the given array like this: 22, 55, 54, 88, 77, 99, 11 and 66. These all value are integers. The next topic is data types of array elements. Here we take an array arr1. We insert each element, and each element is integer type: 4, 9, 7, 13, 2, 6, 11 and 12. All are integers type. In arr2, we have taken a character type value A, B, C, D, E, F, G, H. All the value are same type. Then this is the valid data structure. This is also a valid data structure because this value, all this value are integer types. All this value are character type. So these both data structure are a valid data structure. But in case of this data structure, we taken here 22, we taken A, we taken B, we taken 8.5. This is not a valid data structure because in the previous slides, in the previous topic, we discussed an array is the collection of similar type of data structure. That means if we create an array that must hold a single type of data structure at the contiguous memory location. But here we take integer, here we take character, and here we take float. That can't possible in the case of array. Now the next topic is types of array. There are two types of array. The first one is one-dimensional or linear array. One-dimensional and linear array. In case of one-dimensional or linear array, we have stored data in a contiguous memory location. And second one is multi-dimensional array. Multi-dimensional array is divided into 2D array, 3D array, 4D array, and ND array. This classification is based on the value of index or indexing. Now, we first want to discuss what is mean by one-dimensional array. One-dimensional array is a kind of linear array. It involves single subscript. That means if we want to declare an array or we want to represent an array, we have used a single subscript, yani single square bracket to represent the given data. Then the array is called one-dimensional array. That means we take int A like this. This is a one-dimensional data. Int B like this. Here we have to use only a single bracket. Then this data structure is called one-dimensional array. Now the main part of the data structure is data structure is syntax. Here data type, which data type you want to, which type of data you want to store in the given array. Second one is name of the array. This is the name defined by user, and this is the size of the array or length of the array. That means how many elements you want to insert or delete or taken in the array. This defined by the length of the array, and the length must be a positive integer because we know that length never to be a negative. Index may be negative, index may be 0, or index may be positive integers, but the length is always a positive integer. We can't take a negative value here. For example, we taken an array can be declared as int ARR 5. That means we have taken a location inside a memory ARR and we store we organize 5 locations continuously inside the memory, and the indexing start with 0, 1, 2, 3, 4. This indexing may be negative. This indexing may be start with 1, but the value here are also maybe any type, 0, negative, positive, but the length of this array must be a positive. If we talk what is the length of this array, that would be 5. This is the length of the array. We stored 5 value in the given array and the index start with 0, 1, 2, 3 and 4 up to 4. This is the how much memory is stored or occupied when we declare a array. This is the formula which is used to find the size of the memory, which is when we define an array will be stored. The memory size is equal to 5 times of the size of int. That means what is the size of an integer value multiply with length of the array, we calculate the whole memory acquired by the given array. In the previous case, we write like this: int arr 5, and the size of the array is 5, and each cell is 5 or 4 byte. Then we have to calculate the address or space occupied by the given array is. If each element having 4, then multiply 5 with 4, that would be 20 bytes. That means the memory occupied by the given array is 20 bytes in a contiguous form. That means 0, then 1, then 2, then 3, and so on. Can we specify the length of the array as point or in a form of decimal? No. We can't write the length of the array like this. That must be integer. Can it be of type other than the integer? No. That is the answer is no. We can't do the length of the array in decimal format or other than integer. The length of the array can be specified by any integer constant expression. It may be an expression, but the value of the expression must be an integer format, not decimal, not character types. Okay. Now the next topic is how the length of the array is to be declared. Here int arr 5, that is the correct method. This is the correct. The length of the array is 5. Here int arr 5 into 3. 5 into 3 gives 15, and this is the correct method to write an array or declare an array. Here we also write 5 plus 3. This is the arithmetic expression, and its value is integer type, so it is also correct. Here we have to declare int a. A is the variable, and a equal to 21 divide 3. This value is also integer, hence the given declaration is also correct. But here we take minus 5. This is not correct method to declare an array. If we want to write like this, int arr 5.3, this is also not a correct method to declare an array, and this is also because the length never to be a decimal or a negative value. So we can't write like this, but these all declarations are correct in terms of syntax. We have write here a note. The length of an array can be specified by an positive integer constant expression. That must be a positive constant expression. Now, this is the main topic of programming, how the macro is declared or how the macro is used to define the given variable. By using this macro, we have to minimize the time complexity of the given program. How we can minimize the time complexity of the given program, we discuss here in brief. Specifying the length of an array using macro is considered to be an excellent practice. This is the good practice in terms of programming. We write has defined n 10. That means n is a variable which value set is 10. That means we set the value of n is 10. By using this n, we have to declare an array int arr n. That means this is the array int arr and like this. In the place of this code, we have to write this, but this is a good practice. This is a good practice because I show in next slide how this is a good practice and this is a not said bad, but this is a not efficient manner or a logical manner to use to declare an array. Because in this case, the time complexity decreases, but in this case, the time complexity will increase. And how the time complexity will increase, we showed in next slide. That this is the macro basic definition, how the macro is used. This code is written before the main function. We have to write this code after the header file and before the main function. This is a program in which we have to show how the macro are used to declare or define the value of a given variable. Here we use a simple array, this int arr 10. The size of this array is 10. We want to enter the value in the given array. We have to use a scanf function and repeat loop for 10 times. Here we want to print the given value of the given array and continue loop for 10 times. But what is the difference when we use macros? In this program, same code we write in by using macro. Here we use macro has define and 10. That means here the size of the array is 10 and here also the size of the array is 10. Here use n. The int arr size of the array is 10. Now we want to print the value or enter the value in the given array. We write code this: for I equal to 0, I less than n and I plus plus. Here simple I write for loop for printing the value of the given array. I equal to 0, I less than n and I plus plus. Just look at this point. If we want change the size of the array, that means if we want write here 20, then we change here 20. Also we change here 20, then we change here 20. How many changes? There are 3 changes. One change here, second change here, and third change is here. But if we use a macro types of coding, a macro definition, at that case, we have to change only at this point. If we change at this point, the whole code will be modified. Here, we write 20, automatically this value is 20. Automatically this value will be 20 and automatically this value will be also 20. So, there is one change here, the all code is modified automatically. But when we do not use a macro, then we need to change all value when we want to change the size of the array. This is the main difference to adaptation or using a macro definition in the given program. And so we tell you macro using a macro definition or macro defined function is the good practice in the terms of programming point of view. Now the next topic is initialization of array. In case of initialization of array, we discussed previous also. Here we write data type of the array. This is the name of the array and this is the size of the array. Here there are 5 value in the array. We write like this: 4 curly bracket 4 3 9 and 7. 4 3 9 8 9 and 7. This declaration also done by this method, but which one is the better for the given array or at a point at the time of declaring an array. This method is better for in all types of array. This is also a method which is used to declare an array. We take int ARR 0 equal to 2, ARR 1 equal to 3. By using this method, we also insert value in the given array. But this is the excellent method which is used to insert the value in the given array. This is also an method which is used to insert the value in the given array at the execution time, and this is also adaptable methods according to this method. So this and this method is mainly good main methods to which is adopting in case of declaring or initializing of array at the point of view. Now, what is the number of element are lesser than the length are specified? What if number of element are lesser than the length specified? That means we have to declare an array of size 10 and we inserted only 1, 2, 3, 4, 5 and 6 elements in the given array. What happened? The rest of the elements must be take value 0. Automatically the rest value is 0, like this. Int ARR 10, this is the size of the array. We inserted 2, 3, 4, 5, 6, 7, 2, 3, 4, 5, 6, 7 and the rest position contains 0. That means the default value of the array is 0. When we does not insert any value at the given location, then automatically compiler assign the value at that location is 0. Why not int 10 equal to blank flower bracket? What is mean by this? This is a wrong method. We can't left empty the curly braces. We have to insert at least one element in the given curly bracket. If we want, if we write like this, int ARR 10 equal to 0, then R1, then this array is valid, but this is the not a valid declaration of array, and this is illegal. You must have to specify at least one element. It cannot be completely empty. This array not to be completely empty. Now, some point about the previous slides. If the number of elements are lesser than length of the array, then rest of location are automatically filled by 0, which is shown in the previous slide. If we inserted less than the number of the length of the array, then the rest element must be a 0. Second point is easy way to initialize an array with all zeros is given by this int ARR A10 equal to 0. That means we initialize all the positions of array by 0, 0, 0, 0, 0, 0 up to 10. All the value of the given array is 0. Now, at the time of initialization, never leave this flower bracket empty. When we initialize an array, we can't left this flower curly bracket is empty, and also never exceed the limit of the number of elements specified by the length of an array. If we have to declare an array int ARR 20 and we want to store 25 value in this array, we can't do it. We can insert lesser number of element, but we can't insert greater than the length of the array. Now, this is the basic parts of programming. What is mean by designated initializers? Designated initializers means we have to insert a given value at a particular location. Sometimes we want like this. We want to insert at first position, at fifth position, 6, at sixth position, 5. Then what we can do, we write like this: A0 equal to 1, A4 equal to 6, and A5 equal to 5. Rest of the element automatically consider as a 0. This 0, this is 0, this is 0, like this. This done by compiler. Automatically compiler set the rest of the element is 0, and at the position which we want to insert the value, it take according to the given syntax. We can take in this sequence at random. That means if we write 4 here and 0 here, that would be also with the same types of declaration. This way of initialization is called designated initialization, and square bracket is called designator. Square bracket is called designator. And this types of declaration is used when the number of entries is the number of 0 entries is high precision. At that case, we have to use this method to declare an array or insert the value in the given array. What is the advantage of this array? This types of declaration and this types of array. No need to bother about the entry containing 0. That means an array having the most of the entries is 0. At that case, we have there is no worried about how the elements inserted or how which position the elements are inserted. We have to write the value at which we want to insert a value, and left the position are which have the 0 entry. Like we want to insert 1 at the position 0, we write 0 equal to 1, and we want to insert 5 at position 8, we write like this. The value of the first position is 1 and the value of 8th position is 5. Rest of the element would be 0. This. No need to bother about order at all. There is no need to write once comes before 5, then we have to write 0 before 8. No, we have to interchange the value. We have to write 8 equal to 5, 0 is equal to 1. This is the same as this. These both statements work the similar manner. The next topic is, this is the most important topic in case of one-dimensional array. The first one is length calculation, and after this topic we have to discuss about address for the given elements. Here we have to find the length of the array. We use the formula length equal to UB upper bound LB lower bound plus 1. UB minus LB plus 1. UB stand for upper bound, LB stand for lower bound. Now this is the given array. We want to find the length of the given array. The lower bound is minus 10 and the upper bound is 30. The length of the array is length equal to UB minus LB plus 1, UB 30 minus 10 lower bound, minus gives plus, and the length of the array is 40. If the lower bound is 0, at that case there is no need to add +1. If the lower bound is 0, at that case we no need to add +1. That means if we want find the length of this array, simply the length of the array is 10, because in this case the array start with 0. Now calculating the address of any element in the one-dimensional array, we used formula address of ith element equal to base address plus w minus lb. W minus lb. I subset of element whose address to be found. I is the elements which address we want to calculate. The next point is base address. Base address, that means at what position the first element to be stored. Next one is W, storage size of one element stored in any array. What is the size of per words in the memory cell? And last one is LB. LB stands for lower limit or lower bound of subscript. It not specified, assumed 0. That means if written like this, ARR 20, at that case the LB equal to 0. In other cases, the value of LB will be given according to the given format. We have to identify the value of the given array. Here we taken an example. Given the base address of array, this is the given array. According to given question, this is the LB and this is the upper bound UB. As 1020, 1020 is the what? Base address, and the size of each element is 2 bytes, and this is W. The memory, in the memory, find the address of A1700. We want to find the address of elements at 1700 position. Now we write the formula address A1700 equal to base address plus W into 1700. That means here we have to use I and minus LB. The base address is 1020. The value of W is 2. 1700 minus 1300. 1300 is the lower bound. Now by calculating the value, we get 1820. This is the address of element at 1700 position. Now we taken another example. In this example, the lower bound of the given array is -10, upper bound is 2, the base address is 999, and the value of W is 2 bytes. Find the location of A minus 1. How we have to calculate the value of A minus 1? We write the formula address A minus 1 equal to base address plus 2 times of -1 minus lower bound. The value of I is here -1. We put the value of I -1 and the lower bound is -10. 99 plus minus plus 10. It would be 999 plus 2 into -1 plus 9 -1 plus 10 gives 9, and now 999 plus 18, that is 1017. This is the address of element at -1 position. By using this concept, we have to calculate the address of any elements in the given array. Now the basics operation of array. By using this operation, we have to alter the given array efficiently. The first operation is traversal. This operation is used to print the element of the array. This operation used to count the number of elements in the array, or if we want to print how many elements or count how many elements in the given array, we use traversal operation to count the number of elements or print the value of the given array. The next one is insertion. This is the operation which is used to add an element in the given array. By the using insert operation, we modify the given array efficiently. The next one is deletion. This is the operation which is used to delete an element from the given array. If we want to remove an element from the given array, then we use delete operation. Next one is searching. Yes, search. This operation used to find the given array, given index of an array in the given array. Next one is update. This is the operation which is used to update an element at a particular index. If we want to modify the given array, then we use update operation. This is the mainly 5 operation in the case of array here, but mostly use insertion and deletion. Now the next topic is application of array data structure. Application. The first application is array are used to implement data structure like a stack and queue. Yes, this is the basic data structure which is used to implement stack and queue efficiently. Next one is array are used for matrix and other mathematical implementation. In case of matrix operations like multiplication, addition and deletion, we have to use array to implement such type of mathematical operation also. Next one is array are used in lookup table in a computer. This is the very fast memory. By implementation of this memory, we have to use array to implement the lookup table. This is the table which contain most recently used data, and that means which data is mostly used. The next one is array can be used for CPU scheduling. This is the basic concepts of operating system in which we have to schedule the given process, what is the order to execution of the given process. At that case, we have to use array. Thank you. This is the whole about the one-dimensional array. Thank you. Thank you so much.